Lesson 5J, the area underneath a velocity time graph. This velocity time graph shows a straight line. Remember, a straight line on a velocity time graph means an object is traveling with uniform acceleration. The slope of the line results in its acceleration. When calculated using the rise over run formula, it results in velocity divided by time, which leads to the units being meters per second or meters per second squared. The units for acceleration are meters per second squared. For our first example, we will use this velocity time graph from earlier lessons. It shows an object that is traveling at uniform motion. Its velocity is a constant of 20 meters per second forward for the entire trip. To calculate the area of this graph, we simply need to recognize that the shape is a regular rectangle. The area of a rectangle is calculated by multiplying the base with its height. In this example, the base is 4 seconds, 4 minus 0 seconds, and the height is 20 meters per second, 20 minus 0 meters per second. The area is 4 seconds times 20 meters per second. Notice how the seconds cancel out. The result is 80 meters. If an object is traveling at 20 meters per second for 4 seconds, it will travel a total distance of 80 meters. The area underneath the velocity time graph curve is the distance the object travels. Let's go back to our first velocity time graph for our second example. This graph is a triangle. To calculate the area, we will need the area of a triangle formula. The area of a triangle is 1/2 base times height. In this example, it's 1/2 4 seconds times 50 meters per second. 4 seconds, 4 minus 0, and 50 meters per second is 50 minus 0 meters per second. Again, note how the seconds cancel out. The area is 1/2 200 meters, which is 100 meters. The object traveling for 4 seconds when accelerating uniformly from 0 to 50 meters per second will move a distance of 100 meters in total. Our third and final example is this graph where the object is initially accelerating in the forward direction, then traveling at uniform motion, 3 meters per second, slowing down, stopping, accelerating in the negative direction or the reverse direction, and then traveling uniformly in the reverse direction. To calculate the area, we will create regular shapes. First, a triangle, a rectangle, a triangle, another triangle, and a rectangle. We'll label these shapes as shape 1, 2, 3, 4, and 5. Now we use the area of a triangle and rectangle equations to solve for the area. Triangle number 1, 1/2 base times height. The base is 2, 2 minus 0. The height is 3, 3 minus 0. The result is 3 meters. Triangle number 2, base times height. It's a rectangle. The base is 2, 4 minus 2 makes 2. The height is 3, 3 minus 0 is 3. The area of the rectangle is 6 meters. Triangle number 3, 1/2 base times height. The base is 3. 7 minus 4 is 3. The height is 3. 3 minus 0, 3. The area underneath triangle number 3 is 4.5 meters. Triangle number 4, 1/2 base times height. The base is 2. 9 minus 7 makes 2. And the height is 2. The area is 2 meters. Rectangle number 5, base times height. The base is 1. 10 minus 9 is 1. And it's 2 units down. So the height is 2. 2 times 1 is 2 meters. Now when we add these all up, the distance traveled is 17.5 meters. If we take a look at this example one more time, we notice that in sections 1, 2, and 3, the object is moving in the forwards direction, although its speed may be varying. And in sections 4 and 5, the object is traveling in the reverse direction, again at varying speeds. To calculate total displacement, we will add the displacements from each of the 5 shapes. Forward distances will be positive displacement, while reverse distances will be negative displacement. So let's take a look at the calculations. Triangle number 1, 1/2 base times height. Base is 2, the height is plus 3. The result is plus 3 meters displacement. Rectangle number 2 is base times height, 2 times positive 3. The result is plus 6 meters displacement. Triangle number 3 is 1/2 base times height. The height is plus 3. The result is plus 4.5 meters displacement. Triangle number 4, 1/2 base times height. The height is negative 2. The negative 2 represents negative velocity. It's moving backwards. The product is negative 2 meters displacement. Rectangle number 5, base times height. The negative 2 represents negative velocity. It's moving backwards. The displacement is negative 2 meters. The result is a displacement total of plus 9.5 meters. To recap, distance equals the sum of areas underneath a velocity time graph. Displacement, on the other hand, is the sum of areas underneath a velocity time graph where the area above the x-axis has positive values and the area below the x-axis has negative values.